so much for joining us this afternoon. Amongst the 20-some thousand people here in many sessions, you could be anywhere. And I'm very grateful that you have joined us today. So with that, we'll kick things off. My name is Gracelyn Baskarin. I am the director of the Critical Mineral Security Program at the Center for Strategic and International Studies in Washington, D.C. And before I jump into our panel of experts, I just want to, what are we discussing today? So I think there's a few things that are really fascinating than artificial intelligence and the nexus with critical minerals. When we looked at how much energy we would need going forward, and we thought about this a decade ago, a lot of people thought that our total energy demand would actually decline, stagnate or decline, owing to the fact that we were making big energy efficiency gains. But nobody really kind of saw what was coming for us in terms of the amount of power and the demand surge that we were going to have owing to artificial intelligence. Wells Fargo has estimated that we're going to have a 550% demand surge by 2026. And that's massive when you already consider that over 600 million people don't have any access to energy, particularly in emerging markets, adding to kind of the global energy shortage. And when you think that, I don't know how many of you use ChatGPT, I probably use it once a day minimum for something, whether it's drafting my email, but it needs about 10 times as much power as that Google query that we've been making for decades. So the fundamental landscape of what powers our modern economy is changing. And one of the big questions that I think our panel will touch on today is how is this actually shifting the demand for the minerals and the types of energy that we need? When we talk about net zero, we talk about phasing out our unclean energy and bringing in clean energy, but actually we need stable baseload power, and we're not just going into substitution where we're phasing out one and bringing another. We're going into additive power mode, which is again why you're seeing copper demand go through the roof. So I'm really excited today because we have just such a fantastic panel of experts here to unpack these, and I'm just here for the questions and to learn with you. So I want to start on my left. I've got Cyrus Hiramanak, who's the Senior Managing Director of M. Klein & Company and brings decades of experience globally working in emerging and advanced economies on this. I have Walid Chetta, who's the president of Middle East and Africa at Schneider Electric. And again, just so much experience here. Fabio Fontana, who's the executive director of data centers at Autonomous. And then Majid Al-Omeid, who is the vice president of digital transformation at SNOD. So I am really excited. So I am going to start, Cyrus, with you. And I'm going to do one question straight across the board to get all of our takes on the same question. So my first question is this: in your opinion, given the experience you come from, how is the world actually going to meet the surge in power quickly? Because the AI economy is here whether we want it or not. In fact, it was here yesteryear. We're just catching up now. How are we going to meet that surge in demand?
Thank you so much. I think if we take a step back, and as you were talking about the surge in energy demand for AI, so today in 2024, the IEA estimates that about 1 to 2% of energy demand came from data centers. And over the next 2 years, that's going to double. So that's going to be 3 to 4%. If we look at the instances of compute that, queries or however you think about the world, between 2015 and 2020, there were about 500 million compute instances globally per annum. So it was pretty stable. And if you look at between 2020 and 2023, that 500 million compute instances have jumped to 1,250 million compute instances. So that's going to be, and that continues to grow as you have more LLM models, more AI, that AI get advanced. So that's going to bring a lot of energy demand. And if we think about it as how are we going to address this particular issue, we have to expand the energy supply. That energy supply will come in the form of more gas-fired power plants. If you look at what in the US, the current administration and the new incoming administration is saying that for the base load power, for specifically data centers, they should put in more gas-fired power plant. There's going to be a more focus on renewables because renewables have to be part of that mix. And in addition, in the longer term, in the short term, you have your conventional energy, oil and gas, coal, but in the longer term, you'll have more of renewables, more of nuclear, and other energy sources like geothermal. And if you think about that energy infrastructure, then secondly, we have to improve the grid. In the US, the grid is old, it's not modern, so it's inefficient, so we have to make a more advanced grid. Like in Saudi Arabia, they invested and their grid is modern, versus if you look at Europe and the United States, that grid infrastructure is very old, so you have to improve that. And lastly, and importantly, there has to be an energy efficiency gain from the compute unit. So if you think about 400 terawatts hours that were used for compute or data centers, about 50% of that energy is required for cooling. So to cool chips, that's not going into compute, that's to make sure that the chips cool down so that the computations can be run. So there is a lot of development of new technologies that are helping, like immersion cooling and two-phase immersion cooling, that will help reduce some of that energy workload.
I think you hit three great points: is building the generation, the transmission, and the innovation. I mean, I know in the US we're going through probably what's going to be our first transmission infrastructure upgrading in the better part of 50, 60 years, and we're not quite ready for it. So it's kind of upon us on a...
Yeah, just to add, if you just look at what is happening in California today, that infrastructure grid was put 100, 120 years, and doing that, ties back into the critical minerals. Like copper is critical for data centers. It's expected that today that's about 80,000 tons of copper, and that's going to grow to about 160,000 tons. So, that interplay, we'll discuss further as we sort of move into some of the other questions.
I think it's a great foundation. Waleed, how are we going to meet this surge?
Yeah, so thank you for having me, and thank you for the comprehensive introduction where you mentioned, the 10 times more data and energy you need when you ChatGPT ask a question or compare that with Google. That, of course, generates a big demand in energy. We will multiply this consumption by 4 in the coming 3 years. And one very important point was said about the energy efficiency of all of that. So the answer of the question is, of course, more generation, but also more efficiency. And as you said very rightfully, a lot of it pertains to the cooling of the chips, not only to bring the power to the chip, but to bring also the cooling to the chip, or the heat out of the chip to the chiller. And for that, there is a complete power chain of energy efficiency that can bring you more than 30% of less consumption or efficiency from what you generate. And that is not a small number, knowing that today AI-driven data centers only pertain for 1 to 2% of the overall electricity consumption worldwide. So when you multiply that by 4, you're talking about a scalability that cannot be afforded just by building new generation. Part of the answer is to microgrids, because you cannot transmit all of that, and you will come to that question about transmission and generation, but also a big part of it is pertaining to the cooling and efficiency. We are developing at Schneider Electric a cooling plate that will be studied with NVIDIA, by the way, and we are deploying that with the recent acquisition of a company called Motivair to do the R&D around that. Because, of course, when you are in an R&D environment, it's not at all as if you are in a development and production. A data center sometimes is very critical. It's just not only for looking for answers to common questions, it's sometimes used for very professional, profound questions to be asked or help in decision making. And in that regard, it's a critical power. When you speak critical power, you don't have right for downtime. Downtime, electricity with water is not the best thing to put together. So cooling through liquid is a big dilemma that we need to solve in the very short term. So power efficiency, cooling, and overall, of course, efficiency in generation. That would be the solution, in my point of view.
Absolutely, and those are very complementary approaches that are both equally necessary in terms of meeting that demand surge. And I think innovation is going to be a very strong theme that features here in terms of how we're going to do all of these things.
Of course.
Fabio, how are we going to meet the surge in demand?
Well, first of all, thanks for having me here. I work for NEOM, the project in the southwest part of Saudi Arabia, and our objective is to build data centers that are fully green by 2030. So first of all, just to complement what my colleague said very well about the consumption, there's been a big shift compared to 2 years ago. 2 years ago, we were talking about only hyperscaler. So we are talking about consumption in data center that range between 4 to 8 kilowatts per rack, which was not a lot. In the last 2 years, this is go up to about 120 kilowatts per rack. They're already designing rack up to half gigawatts. So as you see, it's a lot. But it's a lot not only for the change you can see from a Google search versus an AI search. Maybe, I don't know how many you know, just to put some number. When you do a Google search, your consumption is 80 minutes of a 60-watt bulb for a Google search. When you do a chat GPT, it's a 9.5 more. So about 9.5 bulb for 18 seconds. So you consume almost 10 times more. Very close to what my colleague said. Now, that means that if you look at the total gigawatts required worldwide, right now in 2024, we are talking about 81 gigawatts of power for data center. By 2030, they are predicting about 230 gigawatts. So it's a lot. That means that the carbon emission consumption, if we continue to use what we do right now for energy, we go for 200 tons to 600 tons or million by 2030. So what can we do different? From one side, definitely, we need to do an energy efficiency, as our colleague said. This is extremely important. Energy efficiency doesn't mean only on the way we build the chip, but also the way we use AI to balance the load of the server. So we do understand where we need the server. When you balance the load, you can balance the cooling you need. That's the first one, energy efficiency. It's also the cooling, as your colleague said. You do traditional air cooling, or you do immersion cooling, or you do water cooling. But this is not enough, because yeah, you can save energy, so you can decrease, but you still need a lot of energy that is sometimes is almost 10% of what you need today. So the second thing is extremely important. We're doing NEO, how we can be green, looking combination of solar, wind, and hydrogen, plus backup battery. How we are going to do that? So we are building by 2030 10 gigawatts of solar panel. And in Saudi, we are blessed by the nature because we can have about 5 kilowatts per square meter of energy per day. That is much more than what you can get in any other country around the world. So that's the first advantage. Second, we have a lot of space to do that. Second, we are building 400 megawatts of wind farm, because we have a lot of wind on the Gulf of Aqaba. That's the second thing. But still not enough, because solar is only during the day. What do you do during the night with the data center? Yeah, you can use the wind, but the wind is not enough. Look at the difference. 10 gigawatts versus 400 megawatts. So what do you need more? You need, for example, hydrogen. Hydrogen, we build a big joint venture for hydrogen in NEOM that can help us to fulfill the need during the night. That's another important thing, because there are applications that do not need consumption overnight. You take AI. As you may know, there are two types of AI, inference and training. Training doesn't need energy during the night, because you can stop working. You can work only during the day. By inference, you need the energy 24/7. So that's where hydrogen step in. Hydrogen is very expensive. If you have close to your premises, you can have this one. So when you combine those three together, solar, wind, energy, that's the renewable, together with energy efficiency, and on top of that, as you discuss, the innovation you can apply even on the circular economy, then you can be fully green by 2030. That's where we are focusing over the next 10 years in NEO.
And I think Saudi, we have so much to learn from it because there's a lot of greenfield project development happening, but also on the renewable energy front, having some of the cheapest wind and solar costs in the world, which gives it a significant advantage in terms of cost competitive, clean
space.
energy in the space.
Space.
I mean, there's benefits to being in a desert. There's
absolutely.
challenges, but there's also many benefits when it comes to solar power.
Yeah.
Great. Majid, how are we going to meet this big demand surge we're kind of in the midst of?
I think we agree that, I'm not sure if we'll be able to answer this question after this great answers that came from my colleague, but it's clearly that the traditional way that's related to the gas, related to the renewable energies, identify specific minerals that would help in order to generate power similar to what you mentioned, that related to hydrogen and lithium, for example, for storage and something. And also there's an innovative, I would say, solutions that to reutilize those power to generate power by itself. And this would help also to reduce and identify another approach to generate this power through better optimization for the processes and maintain the energy in a better way. I can give an example. For example, 3% of the consumption in USA goes to the data centers. And we're expecting that by 2030, it will jump up to 11%. And this is, I would say, just a start, considering that with all those consumptions that used by ChatGPT, and I believe we did not start. And we should not ignore one more thing also. In NVIDIA, for example, they just announced that you can do AI in your house. You don't need a data center to do this, which means that there's another source of demand that will create it, similar to what we have in EV cars. So how we'll do it? We have to do all the options. We explore all the options. Good luck in you. But it is a serious issue that all the options that I believe that it's not enough to consider the demand that we will have in the next couple of years.
I want to pick up on your first point, because we are at Future Minerals Forum after all, so it does feel very appropriate to talk about the minerals that we should be targeting.
Yes.
We know that a lot of base metals prices this year had a really rough year. Copper went through the roof in 2024. It hit an all-time high, owing a lot to that AI kind of demand.
Yeah.
Also, I don't know if you saw the Financial Times published an article the other day that uranium prices were being driven up because of AI data centers, because again, you need the power from them. What minerals should we be thinking about in this context as it relates to that AI demand surge?
I would say clearly that related to the power, lithium is the main, I would say, that mineral that's needed and required in order to maintain the power. Uranium, for example, it is a start. Copper, and I would say anything that would help us to create a power that it will need it. And for me, I believe that we need to explore all the options. Those are the three main minerals, but still, I believe that we will not achieve to support all the demand that we're having today, considering all the prediction that come in the future.
I think if I can add to that, that's on the power energy side. But if you look at the chip itself, so today the chip is silicon metal. And the silicon metal, as you increase the power density, that chip can't be stable with just silicon metal. So you need germanium and gallium. And those are two critical raw materials when 90% of the production or more comes from China. And so they are critical raw materials that are going to become increasingly important over the next few years as NVIDIA releases out the Blackwell and the other chips that are needed for that AI inference. So the energy density in the chip is increasing, and we need germanium and gallium.
And to that point, these are the commodities that have become the most weaponized when we look at restrictions globally, are really hitting at those semiconductor minerals, right?
Yes.
And so that's kind of a very interesting mineral space to come to. So one of the questions I want to start, so everybody, the rule now is everybody's got 90 seconds in the interest of time. How should we be thinking about cooling? What does it take? Cooling keeps coming up. We are obviously living in a climate era where cooling is important, it's difficult, it's getting warmer. When you're thinking about doing this at scale, we got to cool it. Oh, I'm going to open the floor quickly here. How should we be thinking about it? What does it take?
I think it has to start with innovation. You know, you've got to get into, as you said, you're developing the cold plate for the next generation NVIDIA chips. But after that, you have to have a two-phase immersion cooling. And in two-phase immersion cooling, you don't need necessarily the water to cool it. Yeah. It's another liquid that you can cool it, and you can actually put the compute, full compute, into and immerse that into a liquid. And there's a company, it's a startup that's doing a lot of work that we've been working with, and they're working with NVIDIA like yourself, that over the next few years, and that would help improve the PUE, which is the power efficiency unit of the rack. Instead of being 1.4, it could be 1.08, so that could be a 30–40% energy efficiency that is currently being worked on. So as those gets released, you're going to see some benefit coming out of that.
I want to go, Fabio, we talked about this congruency between, you know, our net zero ambitions, cleaner energy, emissions reductions, but needing to build a lot of energy baseload power really fast. Are these, can we align kind of the clean energy transition with building enough energy at scale?
So we have a two-phase plan. The first one, because the energy demand is going very up on the data center, the current grid cannot cope because it's too much. So there are two phases we are doing. One is to greenify the existing grid, so to make it greener, but it doesn't happen overnight because the grid is going to serve not just the data center, just to serve the rest of the city. The second thing is to build facility close to the data center that is not only renewable energy. So what we are thinking now is to look new technology. One is a small modular reactor. Those are very, first of all, they are safe. It's not like a nuclear plant. They are safe, they are small, but in a small container that is like this part, you can have up to 200, 300 megawatts. So it's a very new technology, but you need to go through all the process of approval and everything anytime you go in a new country, like Saudi. But that's something that can help to cope with the demand of energy in a very short time, a small nuclear reactor. The second thing is talking about what you say about cooling. So for sure, immersion cooling is a new thing we are looking, as you said, on the two-phase immersion cooling. We're also looking at water cooling, because the majority of the chipset, not only NVIDIA has 95% of the market share, but as you may know, there are new companies coming on the market, like Grok, like Cerebras, they are doing inference and training, and they are doing water cooling as well. So that means that even all the ecosystem need to adjust to the new way the cooling is going to be done, because it's not just a traditional cooling, you need to have liquid cooling as well. Last but not least, even in the cooling, like in the energy, we are looking new technology, innovation like the small nuclear reactor. In the cooling, a new technology, we are start looking at that, even if it's not available before the next 5 years, is cryogen cooling, where you go down to 120 Kelvin. And that's what is being using today for the quantum computing. But again, the quantum computing is not ready before the next 5–10 years. But you need to start looking at that, because you need a different design. So to go back to your point, from one side, the grid you have right now is not enough, so you need to have alternative like small nuclear reactor. And the cooling, you need to be more creative of the way you cool. After the air, you do the immersion cooling, liquid cooling, and now cryogen in the future.
Thanks so much. So definitely cooling being a very key and that nexus with innovation.
As you said, 50% is cooling.
Yeah. Walid, how do we improve efficiency? So efficiency is the other thing that continues to come up.
So what I liked about the comment of Fabio on the fact that you can use AI for improving the efficiency of AI-driven data centers. So the answer to the question is including AI. What we use is that we use softwares that run algorithms on the behavior of the data center. For buildings, for example, like the one we are in now, you can just use AI-driven softwares and reduce 30% of your bill of air conditioning, of lighting, etc., on the consumption of energy of a building. The data center is a building with a very heavy consumer that is the chip, but it's a building also. So when we speak efficiency, it's all about algorithms and digitization that will make the energy used, when it's needed, not when just to blow in some cold air into the data center or the water. I like very much the comment on the fact that when you are talking about training AI, you don't need the electricity in the night, so renewable energy and solar energy is very applicable. To manage that, you need advanced softwares that will use the experience of the previous days and years, which is typically what AI is doing, to implement during a given day, during a given week, the right structure of electricity that you will give to the installation that happens to be a data center. So for us, the efficiency, I would say 70% of it comes from software-driven solutions for the data center.
Very important, the software component. So one last question. Majid, I'm going to start with you, and we're going to come back around this way. What forms of power are you feeling most bullish about? Because when we think about the minerals for the kind of meeting the surge, it depends on what kind of power. What is our baseload power? What is our energy mix? Are you feeling particularly bullish to nuclear solutions, gas, wind, solar?
I think that considering that the risk that we are having today, that the consumption is increased like crazy. We don't know exactly what will happen in next 3 years, assuming that, in 2022, we don't know what is ChatGPT. But today, it's a basic activity that can be utilized by any person, even my child. And due to that, I believe we need to have all the type of mix of powers. Gas, I think it will remain for the next at least 20 years, considering that still the other options is not mature yet, cannot provide enough energy, especially that Fabio just mentions, data centers. It's required electricity 24/7, which means that you cannot take a risk of having other options.
Fantastic. Fabio?
So it depends on where you live, where you are. So NEO, for example, we don't have natural gas. So for us, it's a solar today. We're saying the future is MRR, the small nuclear reactor. That's what can make the difference, combined with wind. But the big part is solar, for sure.
Yeah, I'm a desert, benefits of a desert. Waleed?
Well, for Schneider Electric, we are not specialized in generation, but for us, what we do in our own operation is that we are targeting to be net zero by 2050, and we are well on track. And of course, the solar and the wind is a good mix, backed up with battery systems. But it's true that the base load, and you said it in the introduction, the base load is a topic when it comes to massive quantities. Then you will need the base load to be either nuclear or another decarbonized source of energy. At least this is our vision.
Fantastic. Cyrus?
I think we have to think about it in short term, medium term, long term. I think short term, gas has to be the solution for base load. I think as we think about the medium to long term, I think renewables, nuclear, and geothermal. So if you look at IEA is projecting that geothermal is going to be about 800 gigawatts by 2050. Nuclear is going to grow from about 100 to 300. So you have to really, because without that, you can't have a clean energy transition and you can't have access to clean power. So I think all of the above have to be part of the mix if we are going to provide the world with reliable, low-cost energy, because that's the key piece.
I mean, I have a new sheriff in town, like you said, in a few days, and Trump is all about an all-of-the-above energy approach and explicitly said AI, cheap energy for AI is really important. With that, thank you so much for joining us. Please join me in saying thank you to our wonderful panelists for bringing this fantastic expertise onto one stage. Thank you.